IBM MQ now delivers improved resiliency using cross-region replication in MQ containers. Cross-region replication for IBM MQ containers ensures high availability and business continuity by replicating critical transaction data across geographically separated regions. This protects against data loss and minimizes downtime during regional outages or disasters, as well as planned maintenance. It also enables faster recovery and seamless message delivery, ensuring essential services remain operational. In this short video, I'll introduce the new feature and give a short demo of a planned switchover. The native HA cross-region replication configuration is implemented based on the native HA solution, and the cross-region replication, or CRR, provides disaster recovery. Native HA uses a group of 3 queue manager instances to maintain a replicated copy of log data. The group automatically elects an active instance by comparing and choosing the best copy of data. CRR extends log replication to include a potentially geographically distant group or region that is also highly available. Using this configuration, your original native HA queue manager is referred to as a live group, and the other new one is referred to as the recovery group. The recovery group receives all the replicated data from the live via an asynchronous connection. When there is a planned or unplanned outage at the main site, the recovery group can pick up all the work with minimal downtime and data loss. You initially define which role a group plays, and then switch the role of a group manually as required to complete a planned switchover or when an unplanned outage occurs. While the two groups in a native HA CRR configuration are connected, log updates are passed to the leader of the recovery group and passed on to the other recovery instances. This is known as replication. Depending on your scenario, there are 2 ways to switch to your recovery group. Firstly, a planned switchover, when you elect to switch between groups, for instance during maintenance. Secondly, we have unplanned switchover, and this is when the switchover is unexpected, for instance due to a regional disaster. You might require to switch from your live group to your recovery group if you want to test your configuration or need to apply maintenance. When you perform a planned switchover, the systems take steps to ensure that you do not lose data or encounter a partition problem. You request a switchover by changing the group role on each of the groups. For a while, both groups enter a pending status while their recovery logs are synchronized. When this is achieved, the groups adopt their new roles, a new leader is elected in the new live group and takes the active role and runs the queue manager. For the unplanned switchover, when the live group goes down, the recovery group cannot detect this as it simply stops receiving replicated log data, which could just mean that there's no ongoing workload. An unplanned failover must therefore be manually carried out by changing the recovery group's role to live and notifying it that the previously live group is disabled so that it does not attempt to replicate data to it. To illustrate a planned switchover, I've set up a demo environment. The architecture consists of 2 OpenShift clusters, each running IBM MQ in a native high availability configuration. Both clusters are managed using the OpenShift GitOps operator, or Argo CD, to maintain consistent and declarative infrastructure and application configuration. A high-level view of the architecture is seen here. As you can see, we have a live cluster in one region and a recovery cluster in another. Both clusters are updated using the GitOps operator. Now, in this short demo, I'll show you the simple and short steps of executing a planned switchover. Here I have my 2 OpenShift clusters open in 2 separate tabs. The live cluster is located in US East. The recovery cluster is located in US West. If I go back to my live cluster and open up workloads and pods, I can see my 3 queue manager instances running, where one is active and the other 2 act as replicas. If I go into the active queue manager and into the terminal, I can write a simple command to retrieve the role of the group. Here I can see the local group name, which is US East, as well as a local group role, which is live. Let's go back to the US West cluster to confirm that it has been assigned the right role and that it has been set up correctly. Similarly, in my recovery cluster, I can see that I have one leader queue manager and 2 followers. Once again, I'll go into the active queue manager, into the terminal, run my command just to confirm that it has been assigned the correct role. As you can see here, it has the group name of US West and the group role of recovery. Now, let's execute a planned switchover by switching the roles of the clusters. To do this, I've prepared a simple pull request in my Git repository. As you can see here, I only have 2 additions and 2 deletions. Without getting into the details of my repository setup, the only thing I've done is switch the role of each queue manager group. I've simply changed 2 lines of code. I've changed the role of the US East cluster from live to recovery, and in the US West cluster, I've changed it from recovery to live. Let's go ahead and create this pull request and merge it with the main branch, and then see what happens in our clusters. First, I can take a look at the pods and see that the old pods are being removed and new ones are being created with the correct configuration. Once the pods have been restarted, I'll go into the live instance of the queue manager and double check in the terminal to see what role it has been assigned. Here in the US West cluster, which, if you recall, was previously the recovery cluster, but I now have switched over to the live cluster, I can confirm that the roles have been successfully assigned. Similarly, I can go into the US East cluster to confirm that it is in fact a recovery cluster. In this planned switchover, we've lost no messages, no data losses occurred, and our applications have automatically reconnected to the instance with workloads resuming as normal. Thank you for taking your time and watching this demo. If you have any questions or want to know how MQ cross-region replication would work in your environment, don't hesitate to reach out to me or any member of the IBM team.